Bismillah ar-Rahman ar-Rahim. So we'll go through this example again quickly. As we said, we're trying to evaluate the performance of stop and wait with ARQ, with automatic repeat request. And we said that the utilization of the channel for the stop and wait is low. And this example illustrates this notion by describing a scenario that we have a stop and wait ARQ system. The bandwidth of the line is 1 megabits per second. What does that mean? The bandwidth of the line is 1 megabits per second. Then if I want to send 1 bit, how long does it take? How long does it take to send 1 bit on a bandwidth of 1 megabits per second? Send 1 bit. The transmission delay. How long does it take to transmit 1 bit on a channel with a bandwidth 1 megabits per second? No, 20 milliseconds is something else. The time that we take to transmit 1 bit for a channel or a pipe of radius 1 megabits per second is simply 1 over A. So the transmission time equals 1 over 10 to the power 6. Or يعني 10 to the power ماشي. يعني هو T is 1 over 10 to the power 6 اللي هو 1 megabits per second. In other words, it's a 1 microsecond. Okay? So this means that if I were to have a time, if we have a sender and a receiver, the 20 millisecond is the time that 1 bit will take to go all the way from the sender to the receiver and come back. Right? So this is the 20 millisecond. Okay? So since 1 second takes 1 over 10 to the power 6 or 1 microsecond, how many bits can I send within the 20 millisecond? Okay? اللي هي 20 times 10 to the power minus 3 divided by 10 to the power minus 6, which will equal to 20,000 bits. So this is another way for me to understand what the bandwidth delay product means. The bandwidth delay product means that if I were to spend 20 milliseconds to go all the way and come back, okay, and the bandwidth is 1 megabits per second, which indicates that in order to send 1 bit, I need 1 microsecond. So if I have a window of 20 milliseconds, then I can send as many as 20,000 bits. Okay? But the actual fact is that the stop and wait ARQ sends actually 1 frame before it receives the acknowledgement. So it sends only 1 frame and waits for the acknowledgement. So the 1 frame itself takes how long to send? 1 frame is 1,000 bits. Okay? 1 frame is 1,000 bits, which takes a transmission time of how long? 1,000 divided by 1 megabits per second, which is so 1,000 divided by 10 to the power 6. صح? Which is 1 millisecond. So for 20 milliseconds, I utilize the channel for as long as only a day, only 1 millisecond. So the utilization of the channel is 1 over 20. صح? So instead of spending the whole time in transmitting, what I actually did is that I sent only one frame, which is 1000 bits, okay, which took 1 millisecond, and I waited for 19 milliseconds waiting for the acknowledgement. I'm not doing anything, waiting for the acknowledgement. So the utilization of the channel is 1/20, which is defined here as 5%. So that's another way of calculating this, the exact same thing. So either you say, okay, in the bandwidth delay product is the amount of bits I can send on the channel within the 20 millisecond, which is the bandwidth times the delay, the propagation delay back and forth, okay, which gives me 20,000 bits. And actually, the actual bits that I have actually sent is 1,000, because I can only send one frame before receiving the acknowledgement. So I send one frame and I have to wait for the acknowledgement. So I sent 1,000 bits, whereas I can actually send 20,000 bits. So again, the utilization is 1,000 divided by 20,000, which is a 5 milliseconds. So either, whatever way you can understand is that either you calculate the utilization based on the actual number of bits that you can send versus the theoretical number of bits that you can send, or by calculating the actual time that you have spent during transmission versus the total time that you have spent to receive the acknowledgement back. The actual time that you sent for transmission for one frame, which is 1,000 bits, you spent 1 millisecond. And you had to wait for 20 milliseconds before you can send again. So you spent 19 milliseconds idle, not doing anything. So just imagine, for this example, if we were to, instead of sending one frame and having to wait, we can actually send 15 frames consecutive without having to wait for the acknowledgement. So in that case, instead of sending 1,000 bits, you will send 1,000 times 15. And the actual utilization of the channel is 15,000 divided by 20,000. So instead of sending one frame, this is not stop and wait then, because stop and wait can send only one frame before it waits. Here we can send 15 consecutive frames. Okay? This is an imaginary example. This is not using stop and wait, but this is actually a motivation for what we are going to discuss in a bit. In that case, the utilization will go up from 5% to 75%. That's really significant. That's really significant. In that case, we can utilize the channel in a lot more efficient way, right? So that's exactly the motivation for the technique go back in protocol. So go back in protocol, it does not require acknowledgement for each single frame. So it defines a window of number of frames that you can send before you can actually wait for acknowledgement. And as we have seen in the previous example, this size of the window or the number of frames that you have to send before you wait for acknowledgement is really dependent more or less on the bandwidth of the channel. Okay? So regardless, what go back in does is that it defines a window, and then it says, okay, we can send these frames one after the other, which means we'll go back to the simplest protocol during that window only. So during that window, you use a protocol similar to the simplest protocol, which is send frames back to back. You don't have to wait for acknowledgement. Okay? So send the frames as they come. But then after this window finishes, then you have to stop. So it's like if you go back to the previous example, we have 15 frames, our window is 15 frames. So what we will do is that we will send the first frame, and we don't have to wait for acknowledgement. We'll send the second, third, fourth, and so on, until we hit the 15th frame. If we do not get an acknowledgement after we send 15 frames, only then we will stop. Only then we will stop. Okay? So the question now is that what is the actual size of the window? And since we started talking about the sequence number, so what is the size of the sequence number? So remember in stop and wait, we said that we need a serial number of actually 1 bit, right? 0, 1, 0, 1, 0, 1, and so on, right? And we can only send 1 frame before we wait for the acknowledgement. Here, we send in general 2 to the power m frames. 2 to the power m, where m is actually the size of the bits of the sequence number. So if the sequence number uses 3 bits, this means that I have from 0 to 7, I have in total 8 sequences or sequence numbers. Okay? So in that case, I can send 8 frames and then wait for the acknowledgement. Okay? So in general, so what does it mean if m is equal to 3? This means that I can have a sequence number of 0 all the way to 7. So okay, so after this, what happens? We go back to 0, right? So we can circulate and go back to 0. So we go 0, 1, 2, 3, 4, 5, 6, 7, and then 0, 1, 2, 3, and so on. So that doesn't mean that you can only send 8 frames and stop, because you can always circulate the sequence number. But you only need actually 8 distinct sequence numbers, and then you can rotate. That's what this means. Okay? So sequence number is 2 to the power m, where m is the size of the sequence number bits. As we said, if the window size is x, or 2 to the power m or something, then we can send, like this example here talks about the fact that our window is 15 frames. What does that mean? This means that we can send from 0 all the way to 15 frames in total, before we wait for the acknowledgement. Okay? So what happens if the acknowledgement comes back from the receiver in the middle? So while sending, for example, frame 0, I did not receive the acknowledgement yet. So I will not wait, like the case of stop and wait. No, I will transmit frame 1, and then I did not receive the acknowledgement. I will not wait 2, 3, 4, 5. After 6, I receive the acknowledgement. What do? Continue 7, 8, 9, and so on.
No, listen. Listen.
Acknowledgement means that the receiver is telling me I have received everything successfully. What do I have to resend then? Okay. So this second slide talks about what we call sliding window technique. So go back and uses what we call sliding window technique. And what that means is, just to be able to increase the efficiency or the utilization of the channel, we will start sending the frames inside the window. And remember, this window is virtual. It's actually marked by 2 variables or 3 variables. It's marked by 3 variables. The start, or the first frame, it's actually a pointer that points to the beginning of the window. Okay. Okay? SN, which points to the current frame under transmission. Okay? And the actual size of the window. The size of the window, which we will talk about in a minute. Actually, the size is actually 2 to the power m minus 1. And minus 1 here is extremely important, and we'll talk about why. So, using these variables, what I have essentially done is that I have divided the stream of frames into 4 different areas. Okay? 2 of them are inside the window box, and the other 2 are outside the window box. The 2 inside the window box are these. So this is actually my window. This is the window box. Okay? And these parts are outside. So the first part here talks about the fact that these are frames that have been already sent and acknowledged, and it's done. I don't have to do anything about them. It's done. It's gone. It's history. خلاص. I don't have to worry about them. I actually purged them from my transmission buffer, and it's all gone. خلاص. راحت للريسيفر. Okay? Inside the window box, there are 2 parts. The first part is frames that have been sent, but none of them has been acknowledged by the receiver yet. So in that case, I'm just waiting for the acknowledgement for these frames, but I don't actually have to wait to transmit new frames. Okay? So this part are frames that have been already sent, but no acknowledgement has been received yet. That's why they are still inside the window frame, inside the window box. This part are frames that are ready to be sent, but have not been sent yet. So neither they have been sent, nor they have been acknowledged. But I can send them without having to wait. Okay? I didn't yet, but I can send them. Okay? This part are frames that I cannot send because they are outside the window box. So I cannot send unless I receive acknowledgement. Okay. So what happens when I receive the acknowledgement? So when I receive the acknowledgement, let's say that while I'm trying to send frame 7, I have actually received an acknowledgement, and the acknowledgement number is 3. What does that mean? This means that the receiver is telling me, I have received up to frame number 2 correctly. Please send me frame number 3. That's what that means. Okay? So in that case, I consider frame 0, 1, and 2 received by the receiver and acknowledged, and everything is fine. So in that case, what will happen here is that I will slide the window, I will shift it to the right with the number of frames that have been acknowledged by the receiver. So in that case, if the acknowledgement number is 3, this means that up to frame 2 have been received successfully. So in that case, I will slide the window 3 frames. So this means that starting from frame 3, I have already sent, but frame 3 itself has not been acknowledged. Okay? And what will happen here is that frame 15, frame 0, frame 1 will now be ready to send. Okay? Will wait in the queue of frames being ready for transmission, which at this point in time, they have not been ready for transmission. So when I slid the window for 3 positions, the beginning of the window has become at frame 3, and the end of the window has become at frame 1. This means that frame 15, frame 0, frame 1 are now ready to be transmitted. Okay? So briefly, so we specify the window size, and we'll talk about how now, because it's not straightforward. And then anything inside the window, I will start sending one after the other. Whenever they come, I send, without having to wait for acknowledgement. Whenever I receive an acknowledgement, I have to do the sliding window technique. I slide, number of positions equals to the acknowledgement number. Okay? So I will keep sliding the window 1 position at a time until it hits the acknowledgement number. If the acknowledgement number, for example, is 5, then I will keep sliding until 4, and then when it starts at 5, then I'll stop. I will not slide anymore. Okay? So this way, of course, the go back N is much more efficient compared to the stop and wait. Actually, when you think about it, stop and wait is nothing but a go back N with a special case of the window size equal 8. 1, best, bravo عليك. That's it. It's a go back N where N is actually 1. So it's like you are sending within the window, but your window happens to be only 1 frame. Okay? One thing to pay attention to here is that the transmission is always in order. Just the fact that I'm able to send multiple frames, that doesn't mean that I can send frame 2 and then frame 4 for any reason. I always go in order. Why am I saying that? What if I don't receive an acknowledgement at all? What am I going to do? Send what? Send which one?
The ready to send. The one at the beginning of the window.
The one at the beginning of the window, bravo عليك, because I have to always send in order. So I have to go to the beginning of the window and send them again one by one. Even if I have 15 frames. And the acknowledgement has been lost, and there is a timeout, then I have to go back from the beginning. I have no other choice. Because here, for go back in, the transmission is always in order. I cannot afford missing the order of transmission. This is a fundamental condition for the go back in technique. Okay? So for go back in, I have the window and I have the sliding window technique. So both together, they can work hand in hand to increase the utilization of the channel. So in that case, the send window is an abstract concept. The send window, which is the window size, is as an abstract concept, which defines an imaginary box, as we said, which has a size of 2 to the power n minus 1. And minus 1 here is extremely important, as I said. Again, this imaginary box is defined by 3 different parameters. The SF, which is the first frame, SN, which is the current frame, and the S size, which is 2 to the power m minus 1. Okay, why minus 1? We'll see now. So the send window can slide 1 or more slots. Lay more slots. As we said, if the acknowledgement comes and the acknowledgement is in the middle of the window, I can slide more than 1 position at a time, right? صح? I can slide 1, 2, 3, 4 until I hit the acknowledgement number and then I stop. So in that case, I can slide more than 1 position in one single time. The receiver on the other side has not changed. يعني from the stop and wait, the receiver is expected to receive everything in order. Therefore, it does not have to have any special handling because it expects the frames to come one after the other. And then when it receives the frame successfully, all it needs to do is just to send an acknowledgement, similar to what we had before. Okay? So in that case, the receiver window is still 1. Why? Because, again, the receiver is expecting to receive everything in order. Whenever it receives 1, it will send it up and then send the acknowledgement. Same thing like stop and wait. So the receiver does not have to be altered in any way, which is good news. So I have actually increased the utilization. Of course, the sender technique has to be slightly complicated, slightly more complicated, but the receiver does not have to be changed. Okay, which is good. So the receiver window is an abstract concept, again, defining an imaginary box of size 1. So just the fact that the sender has to use a general window size, it doesn't mean that the receiver has to change. Why? Because the receiver, again, is receiving everything in order. It cannot receive frame 4 before frame 3. So it always points to 1 frame. This is what I'm actually expecting. If I receive anything out of order, I will discard it. I'm expecting only 1 frame. That's what I'm expecting. Okay, we'll see that. So the window slides only when it receives a frame successfully, and then it sends an acknowledgement and advances the pointer by 1 position only. So that's how it looks like. So the algorithm itself, again, in a high level, is similar to the stop and wait. So again, here we have 3 different events. So from a high level point of view, it's still the same. We are expecting 3 major events. One is the request to send from the network layer. The other is when I receive an acknowledgement. Okay? And the third one is that if I send multiple frames without receiving an acknowledgement, then I time out. When I time out, I have to go back to the beginning of the window and keep transmitting from the beginning. The receiver, as we said, does not have to change at all. So here, all I need to do now is when I try to send, I need to do something in the windows. Now, I have, for the window, we said we have 3 parameters. The SF, SN, and S size, or the window size. Okay? So I need to maintain these 3 parameters in every event. That's what I need to do extra. In stop and wait, I didn't have to have all these parameters, so I didn't have to maintain these parameters at all. It was much simpler. But here, I have 3 parameters, and I have to increase 1 parameter, check whether I'm outside the window or inside the window, because if I'm outside the window, I have to stop and wait for the acknowledgement, and so on. So that's the code. Sorry, first, in a timing fashion, this slide explains, and this is very important, it explains why we need the window size to be 2 to the power m minus 1. And minus 1 here is very, very important. So, for this scenario, imagine if I have a sequence number from 0 to 3, which means that m is equal to 2. So 2 to the power n is 4. So I have 4 different sequence numbers, right? So what I'm claiming now is that the actual window size, which is the size of the imaginary box that we're talking about, should be actually 2 to the power m minus 1, which is in that case 3. So the maximum window size is, in that case, 3. I cannot use 4. So if it's 3, this scenario will go as follows. And the scenario is very simple. The receiver is actually has a very bad channel. Whenever it sends an acknowledgement, it gets lost. Whenever it it sends acknowledgement, it gets lost. So let's see what will happen in that scenario. So at the beginning of the window, I have SF at 0 frame. So I will send frame 0. Okay, send frame 0. So in that case, the receiver will send an acknowledgement. The acknowledgement got lost. Okay. Well, I'm using window technique, so I don't have to wait. So I will send frame 1. Send frame 1, send the acknowledgement. Acknowledgement was lost. Then, well, again, I don't have to wait. Send frame 2. Send frame 2. Acknowledgement was lost. Okay? So at this point in time, I cannot send any further. Right? Because the window has finished. Okay? So what will happen? From this point, I will have to stay idle until the timeout happens. The timeout says that, okay, it's been a long time and I did not receive any acknowledgement, in which case you have to go. This means that all the frames that you have sent before have not reached to the receiver. So something wrong happened. So in that case, when the timeout happens, what I'm going to do is that I will have to, if I'm pointing here, I will have to send frame 0. Right? So I will have to go back and send frame 0. So frame 0 will arrive to the receiver. Okay? Remember, the receiver has advanced the pointer 3 times, received frame 0, received frame 1, received frame 2, and then it's expecting frame 3. It's expecting frame 3. What did the sender send now? Frame 0, because the sender says that it seems that frame 0, 1, 2 have not reached, or maybe the acknowledgement was lost. So this means I have to go back from the beginning of the window and send frame 0 again. So despite the fact that frame 0, 1, 2 have actually reached the receiver, but for the sender they didn't, because I did not receive the acknowledgement. So in that case, frame 0 will arrive. What will the receiver do here? Discard, because it's expecting frame 3, and it received frame 0, in which case it will discard it. That's correct. That's a correct behavior. This is the correct behavior.
What about the acknowledgement? It won't send that.
Well, hopefully, it will send an acknowledgement. Bravo, it will send an acknowledgement with acknowledgement number 3. So it will receive the frame 0, and we'll see. This is a good question. It will send an acknowledgement with acknowledgement number 3. So every time I discard, I'm expecting frame 3. Do not send me any other frame. I'm expecting frame 3. That's what the receiver will keep saying. Okay, so hopefully, when it sends acknowledgement 3 next time, hopefully this one will not be lost. Or even if it is, then for me, I will send frame 1 again, I will send frame 2 again, and then I will time out, and then I'll go from the beginning. But I will not advance any further until I receive an acknowledgement correctly at the sender. In which case, when I receive the acknowledgement correctly, I will slide the window. Only then I can send frame 3. Right? So only then I can send frame 3, and then the receiver will accept it and so on. Let's see if we have increased the window one position further. If the window size is actually 4, not 3. Which means that the window size is equal to the sequence number. So in which case, frame 0, frame 1, frame 2. After frame 2, I did not receive the acknowledgement. What will happen? Well, I still have one more frame inside the window, right? Okay, so let's send it. So I will send frame 3. Okay? So the receiver will now advance to frame 0. The receiver is expecting frame 0, not frame 3. Remember that. That's the slight change here. The receiver is expecting frame A 0. And which frame 0? This one, not this one. Those are two different frames. When it comes to the content, these are different frames. صح معي? Okay. So when I time out, I will go back to the beginning of the window, and remember I did not slide the window at all because I did not receive any acknowledgement. So I will go from frame 0. Which frame 0? This one. Frame 0 will actually be accepted by the receiver. So frame 0, this one will be accepted as this one, and it will be inserted in the buffer as if it's this one, whereas it's wrong. معايا? This frame 0, this is actually this one. صح? It's the one here. So it should be put in this buffer. But what will happen is that the receiver will think that it's this one because this is the one that it's expecting. So it will admit it, it will accept it, and it will put it in the buffer here. And this will corrupt the whole thing. Okay? So it's very important to see this notion that the window size has to be less than the sequence number by at least 1. At least 1. Okay? So this is the important concept. So go back, and the size of the window must be less than 2 to the power m. By at least 1. Okay? And the size of the size of the window of the receiver is always 1. Because the receiver always expects to receive things in order. ماشي? So as long as the sender window is less than 2 to the power m by at least 1, and the receiver has a window size of 1, then we're fine. Then the algorithm will work fine. Okay, so we'll talk about this next time.